All right, guys, so welcome back. This is the second half of our lesson on factoring binomials. So now we're going to talk about the sum and difference of cubes, or the difference and sums of cubes. And what it says at the top of the notes is just don't forget to use soap, which is important because whenever you take a shower, you make sure that you use soap, otherwise you stink. So let's talk a little bit about some examples of perfect cubes with numbers. So remember, a perfect cube is when a number has been multiplied by itself 3 times. So like 1 times 1 times 1 is 1. So 1 is our first perfect cube. Well, technically 0 is our first perfect cube, but we skip that. All right, 2 times 2 times 2, or 2 cubed, is 8. 3 cubed is 27. 4 cubed is 4 times 4 times 4, which is 64. All right, 5 times 5 times 5, 5 cubed is 125. And really, we want you to know up to about 10 cubed, but remember, you can always double check with your calculator to see if something is a perfect cube by hitting math option 4 to cube root. Okay, that'll change in the future with Desmos, but for right now, we're here. So some examples of perfect cubes and variables. Well, x to the first power is our first x that we come across, and then we cube it. 1 times 3 is 3, so we get x cubed. That's our first perfect cube. What if we want to cube x squared? Well, 2 times 3 is 6, so we get x to the 6. What if we want to cube x cubed? That's going to become x to the 9th. X to the 4th cubed, that becomes x to the 12th. Hopefully you're noticing some patterns here in that every single exponent, okay, for perfect cubes, it has to be a multiple of 3. So any exponent that is a multiple of 3, if I could spell exponent, that'd be nice. So exponent, that is a multiple of 3, is a perfect cube. Cool. So here are our two formulas, and they look overwhelming, but I promise you the more practice you get, the better that you'll be with them. So you do need to memorize both of these, but the good news is they're really the same thing for both. So our first one is a difference of cubes because there's a minus sign between the a cubed and the b cubed. And our second one is our sum formula. Again, not too crazy because it's a plus sign. All right, and this is how it goes. All right, you have a squared, b squared. Same thing with the sum. You have a squared, b squared. Now, what we also need to do is remember to use soap. So I'm going to write out the word soap here in different pretty colors. So we have an S, an O in green, an A in red, and a P in purple. Okay, so the S in soap stands for same. The O stands for opposite. The A stands for always. Sorry, always. And the P stands for positive. So let's talk about what that means. All right, so same means the same sign. So if it's a difference of cubes, we're going to start off with a difference there. Don't worry about soap until the very end. You don't put on soap at the beginning of your shower. You put it on at the end, and then you got to rinse it all off, right? So same is what we do first. That's the same. All right, and it's the same with addition. Whenever it's a sum, you have the same sign. So there's your same. All right, then what comes next is our O, our opposite. So we have to use the opposite sign here. So if we started with a difference, now it's a sum. If we started with a sum, now it's a difference. Okay, so minus sign. And then AP, always positive. All right, so always positive is that last bit right there. There's always going to be a plus sign right at the end. So always positive. So let's do some examples of it. All right, so problem 1 says 125 x to the 6 and 64. We still ask ourselves our question. Whoops, I actually skipped an example. If we scroll down to the bottom, you'll see there's an actual example. We have 8x cubed minus 27. Is there a GCF other than 1? The answer is no. Now we say how many terms? There are 2 terms. Are they squares, cubes, or neither? Well, these are cubes because 8 is really 2 times 2 times 2, and x cubed is x times x times x. So our a value here is 2x. 27 is 3 times 3 times 3. So our b value is 3. It really doesn't matter for cubes if it's a sum or a difference because we have a formula for both of them. So let's follow the formula. So our formula goes like this. A squared, a times b squared. What was our a value? It was 2x. Our b value was 3. Now, a squared is really 2x whole quantity squared, or 2x times 2x, which gets you a total of 4x squared. A times b is taking the 2x and multiplying it by the b value of 3. And 2x times 3 gets you 6x. B squared is taking 3 and squaring it, and 3 squared, 3 times 3 is 9. Now you just have to remember to use SOAP. So remember, same sign. What sign did we start with? A minus. So same sign. O stands for opposite sign, and the AP is always positive. And there is our fully factored problem. There are 2 more practice problems. If you want to pause the video and try them yourself, go for it. If you would like to follow along with me, I'm going to do the next one and the following. So 125x to the 6 plus 64. Is there a GCF other than 1? No. How many terms? 2. Are they squares, cubes, or neither? These in particular are cubes because we know that 5 times 5 times 5 is 125. X squared times x squared times x squared is x to the 6th. 64 is the same as 4 times 4 times 4. So now we figured out that our a is 5x squared and our b is 4. So now we just have to remember our formula. And I do chant it all annoying like. So a, b, a squared. Now this gets a little bit tougher because you have to remember it's 5x squared squared. So that means 5x squared times 5x squared, which becomes 25x to the 4th. Be careful on that. A times b, we're doing 5x squared times 4 to get 20x squared. And then b squared is 4 squared, and 4 squared is 16. Now we just have to remember to use SOAP. So same sign. We started with a plus. We got to start with a plus. Opposite sign is a minus, and then always positive. And that is fully factored. The last one, is there a GCF other than 1? Yes. This time we have a 16 and a 2, so we can take out a 2 from both of them. That leaves us with 8x cubed minus 1. Now look inside your parentheses because we know the 2 is already fully factored. So 8x cubed minus 1. How many terms? 2. Squares, cubes, or neither? In this case, we're dealing with cubes. We have 2x times 2x times 2x, and the 1 is really just 1 times 1 times 1. So our a value here is 2x, and our b value is 1. Remember, the 2 that was the GCF, that just stays out front, and then we set it up like normal. So a, b, a squared, or 2x whole quantity squared, which is 4x squared. A times b, 2x times 1, which is 2x, and b squared, or 1 squared, which is just 1. And then we remember to use SOAP. So same sign. What did we start with? A minus, so we still have a minus. Opposite sign, which is a plus sign, and AP, always positive. And there's our fully factored problem. Please make sure you practice this and do your homework.